For the collision, we need to know the initial velocities of the particles involved. We can get these velocities by differentiating the displacement vectors with respect to time. Assuming I and j are unit vectors in the x and y directions, that gives us an initial velocity of 2 for particle A and -1 for particle B. We can also use the time for the collision that we worked out in the previous part of the question to work out the x and y coordinates at which the collision takes place. Before the collision, the particles are moving towards each other with the velocities we've just worked out, while after the collision they have to be moving along the same line but with new velocities VA and VB. To solve this problem, you're going to need to conserve the momentum, remembering it's a vector, and the energy during the collision. You can either look at this just simply as a one-dimensional problem, conserving the momentum along the line y equals x plus 2, or you could treat it as a two-dimensional problem and conserve the momentum separately in the x and y directions. You can then use the position of the collision as well as the velocities of the particle afterwards to get their position vectors at a time tau after the collision. The position vector of A after the collision is given by x collision plus tau times the component of its velocity after the collision in the x direction, all multiplied by I, plus y collision plus tau times the velocity component in the y direction after the collision, all times by j. You'll also get a similar equation for the position vector of B after the collision.